How did she do that?
Do what?
Land on her feet. She was...
Upside down.
Are you asking me? How do cats land on their feet?
How did she do that?
There's a short answer and there's a long answer. The short answer is they use their ears, their flexible spines, and the basic physics of motion to floop themselves around midair. The long answer is long, so buckle up or something. Before I actually explain how cats do what they do, I want to explain one of the reasons it's so damn cool. And I have 2 words. Emergent properties. An emergent property is a thing that is greater than the sum of its parts. This blade of grass isn't just one thing, it's so many things. It's atoms coming together to form molecules, coming together to form cells, coming together to form tissues, coming together to form a blade of grass. And it's not even that simple, because some of the molecules come together to form different kinds of cells, which form different types of tissues, all of which are necessary to make a blade of grass. And this just happens. There's no little molecule conference where they all get together and they're like, okay, let's make a blade of grass. The division of labor is like this. You guys, you're gonna make this cell and this tissue, and you guys are gonna make this cell and that tissue, and then we're gonna come together, blade of grass, done. When I put together that emergent property, along with all the other emergent properties that come together to form me and my lungs and my consciousness, do you know how many emergent properties make you? There are so many. So many. But you know what? I could count them more easily than I could quantify my love for you. I love you so much. I love you so much. Jeez. There are so many things in a cat that rely on each other to function. That alone makes the cat an emergent property. You can have all the organs, all the pieces, but you won't have a cat until those pieces start working together all on their own. Wow. The muscular system would be useless without the nervous system, and equally so without the skeletal system. The nervous system provides the muscles instructions, twitch tail now, and the skeletal system provides the muscles with structure. Otherwise, the muscles would just exist in a twitching heap and it would be tough to go anywhere. A cat's ability to right itself depends on their cool, flexible spines and the fact that they don't have collarbones that are attached to anything, but also, among other things, on something tiny and essential called the vestibular system. It's small and it's weird, and it exists in the inner ear. The vestibular system, or the vestibular organ, has one very important job: to help the brain figure out how the body is positioned and moving in space. This system is what helps your eyes track movement, even when your head isn't staying completely still. My vestibular organs, I have one in each ear, are telling me that I am upside down. Of course, I could have figured this out myself, based on what I can see and the fact that my blood is pooling in my face. I should probably come down now.
What? Oh, how does the vestibular organ do that?
What a great question, I'm glad you asked. It does this with the magic of circles and hairs. We're not so different, cats and I. We've both got one vestibular organ in each ear. So do most animals. Wild. Here's something even more interesting. Each vestibular organ has not one, not two, but 3 circles filled with pus. That's an oversimplification. They're not actually circles, they're semicircular canals, and they're filled with endolymph. And they look like this. This thing is the canal itself. It's full of liquid that moves with the head, but it lags behind because of inertia. Like if you have a glass of water and you move too fast and it spills over the side and you feel like an idiot because who even drinks water? FYI, when you're drunk and you get the spins, this is why. As Matt Murdock says,
it's an equilibrium thing. It's not your eyes. Liquid in your inner ear gets disturbed, has trouble leveling off or something.
This is the crista ampullaris, another emergent property. It's got little parts in it. This thing is called the cupula, and the endolymph moves it around when the endolymph gets moved around by inertia from the head moving. That movement happens to bend the cilia of the hair cells, which are basically weird long epithelial cells, and that affects conductance of ion channels. In turn, that affects the release of neurotransmitters into the synapse that's actually right there by the ear. And from there, it's a simple transduction of the chemical signal into an electrical signal that tells the brain what the ear is detecting, and the brain can turn this raw information into a sense of spatial orientation. Incredible. What's that? Why are there 3 of these goofy circles in each ear? Well, I'll tell you. I can't point to this because it's not real, but this is roughly how the semicircles are positioned in relation to each other. By having 3 different semicircles in the 3 different dimensional planes in which we mammals can move, we can perceive a full range of possible motion. Incredible. Back to the details of how this works, though, because it's really cool. Up here, we've got them hairs. They're not really hair. This is hair. But they look like hairs, and we humans are simple creatures. They're really called kinocilia and stereocilia. Down here, at the base of the hair cells, we've got these dope synapses that connect to the appropriate sensory axon, that axon being a brain cell's arm, which it reaches out to grab information about what's going on, because brain cells exist inside the skull, where it is very, very dark, and they want to know about the world around them. That's a joke, because individual brain cells can't want things. You have to have a bunch of them together in order for them to want anything, because desire is an emergent property. Getting back on track, when these hairs move, they change how these little pathways let things through. These pathways are called ion channels, and they are channels for ions to pass through. The passage of ions affects the release of neurotransmitters into the synapse down here. And whatever information shows up there in the synapse gets transduced from a chemical signal to an electrical signal that is one that the brain can understand. So with all these different hairs and all these different semicircular canals on 2 different sides of the head, the brain can tell exactly how your head is tilted around and which way is down. Balance is an emergent property. So that is the long version of the answer to your question.
Can you sum it up for me? Because I still don't understand how cats land on their feet.
Yes. The vestibular system tells the cat where she is in space and which way is down. From there, the cat bends in the middle of her body so that the front and back are rotating on separate axes. The cat manages to do all of this while conserving angular momentum. The cat then tucks in her front legs and extends her back legs. This reduces the moment of inertia for her front half and increases it for her back half. That's a complicated way of saying it lets her rotate her front half more without her back half rotating the other way as much to compensate. Then she does the opposite. She tucks in her back legs and extends her front legs, and rotates her back half. She might have to do this more than once to get turned all the way around, but the end result is the same. Mid-air, she is now oriented with her feet ready to catch herself on the ground.
Can you explain it a little shorter?
Question. How do cats land on their feet? Answer. Their ears tell them which way to twist.